Thermoelectric coolers for security cameras. Increasing concerns about public safety and security are driving demands for video surveillance cameras. CCTV and IP security cameras are installed at shopping malls, hotels, around entertainment venues, and private properties. Thermal cameras utilize infrared sensors to improve facility and border security at night. According to Markets and Markets, the video surveillance market will continue to grow from $45.5 billion in 2020 to $74.6 billion in 2025. Global Markets Insights reports that the IP camera market size alone was valued at over $8 billion in 2018 and will grow at a compound annual growth rate of 14% from 2019 to 2025. The infrared camera market is expected to grow 7% between 2020 and 2026. Thermal imaging technology is now being implemented in many security cameras for detection at night. Instead of the 400 to 700 nanometer range of the visible light camera, infrared cameras are sensitive to wavelengths from about 1,000 nanometers to about 14,000 nanometers. 3D security cameras are also improving image quality as they provide in-depth images of an object. This technology is frequently used in applications such as robotic positioning and automation inspection, but has also been introduced to sports stadiums and entertainment venues to improve attendee experience. Digital cameras use two main types of imaging sensors: CCD sensors and CMOS sensors, which both require active cooling. The internal electric power from more advanced 3D camera systems can generate more than 60 watts of heat. In combination with solar radiation, outdoor camera applications may see operating temperatures as high as 90 degrees C, which exceeds their maximum temperature limit. To improve capabilities and functionality, modern security cameras feature more electronics in smaller footprints, which can negatively affect airflow while increasing heat flux density. Because thermal cameras are detecting radiated heat, heat from passive internal components makes it harder to capture images. Any heat generated from the camera system must therefore be managed and quickly dissipated. To reduce the thermal resistance of the hot side heat exchanger, airflow needs to be taken into account. Fans or liquid heat exchangers add costs and require space within an already space-constrained design, which can prove challenging. Camera designs that completely seal the camera components from water or dust can also affect airflow and make it difficult to route heat away from sensitive components. Most often, the enclosure must feature a cold plate that conducts heat through a heat sink or heat pipes to transfer heat. In addition, cooling vital components can result in the creation of condensation. Since outgassing must be avoided at all costs, protective exteriors are important to prevent moisture from forming on sensitive camera components. Active thermoelectric devices, such as thermoelectric coolers, are used in conjunction with passive heat sinks to offer spot cooling and rapidly move heat away from sensitive electronics. By utilizing the Peltier effect, it creates a temperature differential across the ceramic substrates, causing one side of the thermoelectric cooler to be cold, while the other side is hot. Compared to conventional heating methods, thermoelectric coolers are much more efficient because they generate heat from input power supplied plus additional heat generated by the heat pumping action. Thermoelectric coolers can create a temperature differential across the module and lower the temperature differential of the CMOS sensor by as much as 30 degrees C from the hot side temperature of a heat exchanger. Heat will then need to be routed through a heat rejection mechanism, such as a heat sink and fan, to get the heat transferred into the air environment. However, it is critical that the hot side heat sink does not saturate. Otherwise, heat will flow back into the device and heat it up. Because standard thermoelectric coolers are not sufficient for operating in high-temperature environments, Laird Thermal Systems has developed a new generation of materials to enhance reliability and cooling performance. The compact HiTemp ETX series thermoelectric cooler has a robust construction that allows it to survive in temperatures up to 150 degrees C, which is well above most outdoor applications. Assembled with advanced thermoelectric materials, the HiTemp ETX series boosts cooling capacity with up to 10% compared to standard materials. It also features a higher thermal insulation barrier that delivers improved temperature differential with a delta T max of 83 degrees C. This series also maintains a high coefficient of performance to minimize the amount of input power required to operate and reduces the heat rejection requirement to the hot side, which is critical in poor heat sinking applications such as security cameras. To meet unique application requirements, the HiTemp ETX series is available in multiple configurations, covering a wide range of footprints, cooling capacities, and voltage ranges. Imaging sensors and other sensitive camera components require active cooling to keep operating temperatures below their maximum limit, ensuring high-quality images and long-life operation. Designers are also tasked with challenges such as thermal noise, size constraints, lack of airflow, and outgassing. By utilizing the Peltier effect, thermoelectric coolers create a temperature differential across the module and rapidly move heat away from sensitive electronics. The enhanced HiTemp ETX series thermoelectric cooler offers a high COP, boosts cooling capacity by up to 10%, and is tested to withstand temperatures up to 150 degrees C, exceeding most outdoor applications. Visit LairdThermal.com to find your optimum thermoelectric cooler or to learn more about thermal management for security cameras. Laird Thermal Systems develops thermal management solutions for demanding applications within medical, analytical, industrial, transportation, and telecom markets. If you have questions or need more information, please chat with us via the website at LairdThermal.com.